There you are.
All right.
Sorry about that. That was my computer.
Well, here we go again. We'll get started up here. And so, yeah, do you have the information of either you or the person who has measured the curvature of the Earth, and which formula did they use, and how did they verify that their measurements were in accordance with that formula?
No.
Do you have an experiment that shows anything with some kind of mass being sucked up into it by the use of gravity?
Gravity is a proof of mass, not form, not shape.
Well, no, but you asked for a few examples of how the globe Earth works, or it doesn't work, and I'm just trying to think of a few questions off the top of my head. So that's two of them right there. Do you have any experiment whatsoever that shows water bending or curving?
That's gravity, yeah.
Yeah, your connection's kind of bad. It's getting kind of choppy over here. Say it again.
You're using gravity as a proof of the globe, but gravity is a proof of mass, not shape.
Well, you asked me how the globe doesn't work. That's one of the main issues why we were all taught in school why we live on a globe, is because one of the first questions that all the children ask is, well, why don't we fall off the bottom? And they say, because of gravity.
Yeah.
If you don't want to use gravity, that's fine. Let's just stick to the measurement of the curvature. What's the experiment that was done that measured the curvature?
That the Greek guy you said for once. Others I don't know, but all daily observations said that we live on a curved surface. Boats going over the horizon. You look at Polaris from the degree you live at. It's that can't happen on a flat Earth.
And I'm sure you've seen the videos of boats that have gone over the horizon that reappear once you get zoomed in, right?
You said zoom in. You don't know how zoom works?
Zoom. Well, sure. You take a smaller portion of the viewing field and you increase the size.
Yeah. How can you zoom something back over massive water?
Can you zoom something back over a massive water?
I'm asking you. How can you do that?
You can't.
You see the boats. You see the boats behind a mass of water. You cannot zoom that back. What's between you and the boat? It's water.
But you can do it if it's flat.
No, because then you don't have water between you and the boat.
You don't have water between you and the boat if you're standing above the water.
Not on a flat Earth.
And you zoom in.
Not on a flat Earth. Water is flat on a flat Earth.
So the boat is sitting on top of the water when it leaves, right?
Yeah, and then it goes a few miles away, and then it goes over the curvature, and you don't see it.
Until you zoom in.
No.
Should we see it? Should we watch it?
If you can zoom it in, it hasn't gone over the curvature. You still have water behind it, and it hasn't passed the curvature.
Well, that's the ancient Greek testimony. That's where the testimony came from. Was from the Greeks that said that they would see ships disappearing over the curve of the water.
Yeah, and the ancient Greeks said the Earth was a sphere.
But then you don't. You see the ships. I mean, they didn't have the zoom-in capability back then, so it's the assumption that the same thing that they saw with the human eye is what we're seeing today with the human eye.
Yeah.
And so,
but on YouTube, you see not with a human eye. You see from a camera, and camera have pixels, and that's pixel size. When you zoom all the way out to 24 millimeters focal length, you don't see it because the boat is too small to be registered on the chip. That's how YouTube is. Go out to the sea and try it for yourself.
So you're claiming the original shot that they take with the camera, in which you can't see the boat, you would be able to see if you're standing out on the water?
With your own eyes, yes. Not on YouTube.
Okay, well, we'll try it out. Yeah, I'll take a look at it and see if we'll find out if you're right. I mean, I can't go to you obviously, but
I don't
you
live
know,
by the sea.
but if
Every
that's your
sing
claim, I'll go find out.
every single video you see on YouTube, you zoom in on the boats. The boats is on the horizon, and when you have that famous P1000, you go from 24 to 3000 millimeters focal length, and we zoom all the way into 24 millimeters. The ship just disappears from the chip because it's too small. But what you see with your own eyes is not the same as you see with a camera.
And so you think all the people going out taking this video are finding ships that they can see and then zooming all the way out with the camera and in an attempt to deceive everyone?
How would you else be seeing it to make a video of it? Should you just zoom all the way in and then
Well,
search for boats on the horizon, or should you see it with your
that's
own eyes and
exactly
then
what
zoom
they
in?
do. That's precisely what they do. They zoom really far in, and then they look around, and then they look for boats that are showing up.
I'm not that sure.
That why wouldn't they?
Because they see the boat
Why would
first.
that be so hard to do?
Because they see the boat first.
Well, perhaps. I find it a little bit odd that all the people going out there are seeing a boat there and really trying to just zoom the camera all the way out in hopes that everyone's just going to keep going with the same story. Everyone, I mean, this is so household experiment now. Anyone can go out there and do that. It just
not everyone, just every other one. Because when the flat Earth believers do it, they do it that way. When we Globers do it, we do it the real way. We see the boats halfway down behind a mass of water. And when you zoom it in, you still see the boat halfway down. You don't see it appear on top. It's behind a mass of water. And what?
Okay, well, I'll go find out. I'll try it out.
And when you see the boat behind a mass of water, how can you zoom it back?
When you see the boat behind a mass of water, how do you zoom it back?
Yeah.
That's your question?
You know how light works. You know how you see things. You have the sun shining on an object like the boat, and the photons travel from the boat to our eyes. You have a mass of water in between. How can we zoom that line of photons down to our camera? How does that work?
That's our claim, is that that's not happening. The claim is that it's flat, and that sort of, twisted explanation is what everyone's trying to cling on to. But I'll find out if you want. I'll go out and I'll see if I see the boat first before zooming in, and then, or if it actually does look just like a flat, empty horizon. And I anticipate that I will be doing what everyone else is doing, and that I'll be zooming in with my camera really far and just looking for boats. And then when I zoom back out, it's going to look very similar to what it looks like on the camera. It's going to look like I'm not seeing anything.
You also have seen those. Sorry.
Yeah, my eyes might not have the full, viewing capability of the camera zoomed all the way out, but I'm assuming whatever the human eye millimeter length, whatever you called it is going to be the same. I won't be able to see the boat to begin with.
Our eyes is about 35 to 50 millimeter focal length to a camera, but when you have that 35 to 50 millimeters, our eyes is about the same quality as the camera. But when you zoom in, we don't have hawk eyes, of course not. So when you zoom in, the camera is far better, of course. But still, if you have seen the videos where the boats are behind the horizon, you have seen those when the boat is hidden by a mass of water, you have seen those videos. Oh, they're all over.
I've seen videos where they zoom really far in and there's distortion from mirroring and other issues going on in the atmosphere.
Yeah, but there's also where there's not any obstructions or anything. You see the waves of the water and the boat behind the water. There are plenty of videos on YouTube.
Right, and there's an account for that when it comes to mirroring and atmospheric distortion and all that stuff.
Not when you don't have any. That refraction is when you see a sharp line between the water and the boat, there is no refraction.
When I see a sharp line between the water and the boat, that's the mirroring effect.
Then you would have that boiling effect. That's refraction. When you see mirroring and then boiling, you have all those distortions. When we don't have a sharp line with the water and the boat, there is no reflection to be seen on the video, and we still have half the boat obscured by water.
Okay. Well, then what's the explanation for that happening in the videos
Curvature,
where that's not happening?
simply curvature. You have a mass of
Curvature,
water.
that doesn't answer the question. What's the explanation for sometimes the boat being behind the water and sometimes it not being behind the water?
Because when it's not behind the water, it's not behind the horizon.
So you have how have you measured that both of these boats were the same distance away and not the same distance, but one boat is closer and one boat is farther?
You cannot measure with a camera.
I know. How have you measured otherwise, being able to tell that one boat is closer and one boat is farther, and that the issue is they just haven't gone over this alleged curve yet?
You see it on the video because you have either water behind it or not. You have water behind it or water in front of it.
Measuring is an experiment where someone goes out on the water and measures how far out they're going.
Yeah.
And they say, see, this boat's only this far out. This boat is this far out. Here's the two different cameras that show the difference in curvature.
Yeah. And when you have water in front of the boat, when you have water between you and the boat, there is the curvature. You don't need to measure it. It's there. It's visual. It's daily observations.
That's not measuring. That's just an observation.
Why do you need to measure it?
Literally measured.
Why do you need to measure it?
Why do you need to measure it? Because that's what we do in science. Measuring is an integral part of the experiment.
Yeah, but yet you see the water. You have a curvature of water and then a boat behind it. You don't need to measure that because it shows that you have curvature. You have water behind you in the boat.
Then what is the explanation for seeing a tower 80 miles away and not seeing the same discrepancy and not seeing the same disappearance?
Atmospheric distortions? I don't know. Everything.
Because if that phenomenon exists over 6 or 7 miles because of a ship, what's the explanation for no curvature as you get up 20 miles high? It doesn't get flatter the higher you get.
No, but you see further.
Sure, but that phenomenon would be more profound the higher you get. It would be more prominent.
You know, you have that flat earthers say you have horizon rising with eye level or something. When you are up in Boeing 747 at cruise altitude, the angle between your eyes and the horizon is 3 degrees. That's nothing. You don't see that. You can't. You said?
Yeah, no flat earther that I know is claiming that you can see curvature from a cruising altitude.
No, but you see that the horizon rises to eye level.
Sure.
Yeah, but when you are up in a 747, that's only 3.3 degrees, and you don't see 3 degrees with your own eyes that far. So whenever you say that's...
The only people who are claiming that are the globe earthers.
No, I have seen it all the time.
You've seen a curvature from cruising altitude?
No, I've seen that the flat earth believers saying that horizon rises to eye level. So when you say...
you're saying that the horizon difference is 3 degrees. Is that what you mean?
Yeah. So when you say that it will be more prominent... When you say the higher you get, the more prominent that curve will be, it's not that much because the Earth is big. So 3.3 degrees. You said it will be more prominent.
Sorry, but I wasn't saying from cruising altitude. I was saying from the high altitude balloon flights, which is, cruising altitude is about 5 miles high. What about the 20 miles high, or in NASA's case, 40 miles high?
They still see curvature, yeah.
Well, not according to NASA's video when they went up 40 miles high in their ship and the horizon is still straight and at their eye level.
You've seen the dog cam video.
Well, that's one of them. That's the 20-mile high one.
Yeah,
and then NASA has a 40
that's curvature.
There's no curvature there, and it's still at high level.
You have one guy who showed it. He took a screenshot and then they adjusted the layers in the contrast in the video, and you see the curvature. because that's the horizon is covered in clouds. So if you alter the layers in the picture, you can see it clearly.
Okay. Do you have that?
I'm gonna find it.
All right.
Dog cam. He called it. Let me see. My computer is kind of slow, but if you go to dog cam, yes, there is curve in the image.
Poor connection or something.
Now my computer is messing up again. Ooh. You still there? There you are. You have a better computer than me. Could you pull up the video?
Yeah, what's it called?
Dog cam, yes, there is curve.
It changed.
The only thing it does is change the levels in the image. And there's the curve. Those lines are not straight.
And what's the difference between here and here and here?
That's the curve.
Well, there isn't three curves. Which one? What's this and this and this?
This is just layers in Photoshop. This is when you posterize a picture. This is just artifacts. This is JPEG artifacts. But you see the curve.
Yeah, I see some stuff curving. I'll give you that. All right, and then what about I mean, these are all at the same height, close enough.
Yeah, but what part of the Earth do you see that is quite a small part? You see very far in front of you, but you don't see that far from side to side.
Perhaps.
Just
Very hard to say.
Small portion.
Well, have you seen this one with the sun? I only brought it up because you mentioned it a while ago, with the sun not shrinking. You familiar with this one?
I've seen some of them, yes, and It looks to not be any solar filter on that camera. And then you have glare. You cannot measure glare.
Let's see.
Yeah.
Get rid of that music. This is not a solar filter?
Nope. Because when you have a solar filter, you see only the sun. It blocks
okay.
out 97, 99% of the sun.
All right.
A neutral density filter is not the same as a sun filter, solar filter. I'm not going to challenge my computer too much to show you, but there are every single one of those is filmed without a solar filter, and it's worthless. You have the ones when you see the sun in front of the clouds and all that, because that's just English dynamic range of the camera and all those. So none of those videos are real. There's easy explanations to everyone. Infrared is one on the yes. What's the properties of infrared light?
What are the properties?
Yeah, you have infrared light there as an example. What's the properties of infrared light?
That it picks up on heat.
Yeah.
As I understand it.
Does it follow the rest of the light's properties?
Does it follow the rest of the light's what?
Properties. It follows the same laws as visual light.
I don't know.
Yeah. Why do you use it as evidence then?
Sorry, you'll have to say it again. I'm looking for something here. A little louder, please.
If you don't know how infrared light behaves, why do you use it as an evidence?
Well, again, I mentioned on all of these videos, I'm not positive that any of this is evidence. I'm just saying that there's a lot of other people out there with, just an alternative explanation, an alternative view.
You have that 500 miles video that someone claims. You see 500 miles with infrared light, but infrared light follows exactly the same properties as normal light. It's just a fraction difference, and that video shows clouds, not mountains.
Let's see. Before we get there, this is something else I thought was kind of fascinating. You seen this government documents admit flat Earth?
Nope. Or maybe I've seen it, I just don't know before I see it.
Yeah.
Government document on my website, which again, a lot of thank you to Pastor Dean Odell, who provided all this information to me. There's a flyer here, really quick, if you're looking for a flyer to hand out. This is an option. So it's 2 pages, front and back, if you'd like. Okay, so now I'm going to move on to the government doc. So click on this page here. From here, I've got some content added at the very top. All the governments on the face of the earth are controlled by Satan. He has deceived the entire world, just as it was that which may be known of God is manifested in power, and God had so, and their foolish heart was darkened. Professing themselves to be wise, they became fools. Romans 1:18-22.
Why do you have the government into this?
What's that?
Why do you have the government into this, or NASA?
Why are we adding government into this?
Yeah.
Well, because government or NASA is the foremost authority on what's going on in the skies and the earth.
But do they decide the shape of the earth?
Well, no, but that's what everyone is going to for the answer.
I'm not. I'm from Norway. We don't have NASA or government here.
Well, you have a government.
Yeah, but not the American one.
Sure, but I assume your government is just involved in scientific experiments as all the others.
Yeah, sure.
But everyone considers government. They're the ones that have the funding and the manpower to do it.
They still don't decide the shape of the Earth.
Agreed. Totally agree with you.
The shape of the Earth is purely a matter of flat or sphere. That is all daily observations. You don't need any government to decide that.
Yeah. Well,
just like
you
Sean Hawkins' model with that Polaris thing. How can that be on a flat Earth?
Well, right, but the government is the one that's basically running the skies. So we would assume that, especially when it comes to aviation and whatever they call that, the air traffic patrol, and especially when it comes to flight manuals, and page 1 of the flight manual says to assume a flat plane.
NASA was built in 1958. U.S. government way before, yeah. Who decided the shape of the Earth before that?
What do you mean? I mean, no one decides the shape of the Earth. The Earth is the shape that it is.
Then you do daily observations to see what it is. Like Polaris. Sure. You said you live in California. Yeah. On a flat Earth model, the angle to the star there is over 20 degrees different to where it's on the globe. On the globe model, you can see it here at 60 degrees. I live at 60 degrees.
Yeah.
And everyone north of the equator can see Polaris according to the latitude angle on the globe.
Right.
How does that happen on the flat Earth?
No one knows. If this place is flat, anything could be going on up there. It could be any running program.
And still even the Earth is flat.
Yeah, because, I mean, if what is going on up there is anywhere near as sophisticated as what's going on down here, I mean, it could be anything.
I don't understand that. We have all the evidence of a globe Earth, and you think it's didn't, but you don't have anything to go on. How can that be?
You haven't even measured this globe Earth.
Many times. So many times.
What is the experiment that has literally measured the curvature?
I don't know.
Someone has gone and actually measured how far they are, how much lower they've gotten, and corroborated that with the formula of the shape of the Earth.
I didn't do it. I don't know how they do it, but it's done. It's done many times.
No, it's done isn't an answer. What's the actual experiment? You say that we have all the evidence in the world. Show it to me. Show me the evidence that the Earth has been measured.
I don't have it.
No one does.
You have internet, all over internet.
Yeah,
same as the flat Earth. You said flat Earth. Who has the pictures of the flat Earth? Who has the pictures of the dome or the ice wall or your side of the moon? Because where you live, you and I don't see the same side of the moon.
Well, it sure would be nice if we could go check without being shot out of the water or shot out of the sky as per international law. We would love to bring everyone a picture, but number one, it's impossible to get because if you even try, you get taken out.
Nope.
And yeah, you do.
There's tourists.
It's international law.
You can go online and order a tourist trip to South Pole.
You can go to highly regulated areas.
How do you know? Have you tried? Have you heard of people being shot?
Yeah.
Have you seen pictures of all the military down there? Not just buildings, but actual forces, army forces. No,
very specific, certain circumstances. You can go visit Antarctica.
I'm asking you, have you seen military forces on Antarctica? Military forces, armed military forces.
Well, I've seen pictures of bases and stuff, and a couple guys standing.
That's research base. That's scientific research base, not army. Army is not allowed down there.
No, I'm not disputing that at all. I'm saying you can go there under very strict conditions.
Yeah, sure. Strict conditions, yeah. Because South Pole is not a tourist trap. It's hostile environment because of the environment. It's cold. It's far away from everything. It's safe.
Says the government.
Safety reason, yeah.
You or I trust.
This is nothing either you and I can prove anything of because that's the only hearsay. What we can prove is daily observations.
Right, which is why I'm telling you we can't get that information to you because we're simply not allowed to.
You don't know that because I haven't tried.
No, I know that I can't just up and just hop on a ship and if I feel like it and just head over to Antarctica. I know that I will be shot out of the water. That's international UN law.
No, it isn't.
Yes, it is. Yes, it is.
It's regulated
It
because of
absolutely-
safety. It's in a hostile environment because of the
Bullshit.
no. But
Anytime you hear the government say it's regulated, you're being lied to.
it's regulated because they don't want to have all the people down there. They don't want
I
it to
am
be
a
a
free
tourist trap.
person on this earth, and I can go wherever I want, whenever I want, without clearance from anybody. And anyone who's trying to tell you that you have to have clearance for safety reasons is controlling you and lying to you.
Just like America, if I stole a car here, I can't go to America.
If you stole a car over there, you can't go to America?
Yes, that's right.
What do you mean?
To go to America, you need to have a what do you call it? You can't have anything on your police record. If you have anything on the police record, you can't go to America.
Yeah, it's immoral.
Yeah, just
It's
the same.
invalid, illegitimate.
That's restricted.
Yeah, it's invalid and illegitimate. That's what we're saying. We're stuck. It's invalid and illegitimate that we can't just go check Antarctica.
Because they don't want us as a tourist trap.
Because they don't want what?
As a tourist trap, you don't want all the tourists down there because of environmental
wow.
research.
Tough. They don't have the moral authority to tell people where they can travel.
But then again, this is just you and me talking about something we cannot check out for ourselves before we do it.
Right.
What I'm talking about is daily observations to prove the Earth is a globe. And you can't do that on a flat Earth.
Why are you asking for pictures of these observations of an ice wall or the edge of Antarctica that I can't give you?
Because you can get it.
No, I can't.
Why can't you get a picture of
I'm
the
not
dome?
allowed to. I'm not allowed to go check and take those pictures for you.
That's where we differ. How can it
It's
get...
UN law. It's international law.
Flat
There's
Earth
a
believe...
UN treaty with all of the developed nations that say we're not allowed to go there.
I'm not agreeing with that, but that again, we can't agree on that one. But
well, let's look up what the facts say then.
Are you one of those who believe you have a firmament or a dome?
Yes.
Yeah. If you have seen that crater in Arizona, how can that be?
I don't know.
What fell down to make that crater?
No one knows.
How can it be when you have a dome in the way?
No one knows.
We know.
No one. I mean, how are you claiming that something fell down to make it?
It's a crater.
So?
Something fell down to make that crater.
Prove it.
It's there.
Okay. So what?
The crater is there. Something had to fall down to make it.
Or not.
How would it else be made? Someone dig it?
Well, we got to go find out. We got to make experiments that can do the same thing.
They did. It's a comet that fell down for many, many thousand years ago.
Show me. I mean, you're laughing, but that's the part of science that we need.
If you ask me to show every experiment, you need to show me how the Earth is flat.
Well, I'm saying by daily observation, it looks pretty flat.
Yeah, sure. No one denies that. Everyone says flat. Because you have to see over 69 miles to see 1 degree. It's
so
big.
here's the Antarctic Treaty, by the way, that we're talking about before we continue on this one. So, I mean, any questions here?
I've seen that one. It's okay.
So you said that we differ.
Because you say you will be shot out of the water. I said it's not military forces there. The only thing they use military for is for transport or for getting supplies. That's the only use of military down there. Man tries. You don't Google this one, because then you have all sorts of answers. That's dangerous.
Okay, well then, what's the big solution? You got another source?
Of what?
You got another source to look up? Because if someone were to do this stuff, where else would it show up besides YouTube and Google?
No, I don't know, but the treaty says it's the military down there is there for transport and bringing supplies. There's no armed forces down there. It's not allowed. You don't claim a territory and have military forces defending it. That's not how it works.
Let's see if I can find it here. I don't remember the guy's name. Let's see if it's this one.
But you also said you believe in daily observations. How come I can't see how can see Orion in the summer? I see Orion in the winter, but not in the summer. Why is that? It should be in the same place.
I think I see Orion all year.
You don't.
I'm pretty sure I have.
You see it in the winter, but in the summer it's behind the sun. That's not working on the flat Earth model.
To my recollection, I've seen Orion my whole life.
Yeah, you see
every night.
Yeah, all life, yeah, sure, but not in the summer.
No, I mean my whole life, like every night, my whole life.
Yeah.
I could be wrong. I'll have to check again this summertime, but
in the summertime I don't see it because it's behind the sun. That doesn't happen on the flat Earth. There's nothing to hide the Orion on the flat Earth.
Yeah, well, I'll check this summer. We'll find out. But to my recollection, I've seen Orion all year, every night.
Yeah, now it's winter now, we can see it, but in the summer you don't. Because the Earth tilts to 24 degrees, and you have on the other side of the sun, you have Orion on the wrong side, so you don't see it.
Well, that's why I said this summer I'm going to check. Because to my recollection, all year, I've seen Orion each night.
Yeah, but check in the summer. You have it now, but in the summer, you don't.
Will do. Will do. I mean, yeah, it's interesting stuff. I'll have to think about it and take a look at these things. I don't recall seeing a completely different set of stars between the winter and the summertime. And again, it goes back to if this place is flat, there could be any running program going on.
We don't live in the Matrix.
You what?
We don't live in the Matrix. You said it's a different. You said it's running a program. We don't live in a Matrix.
Right. But I mean, it could be any kind of sophisticated creation going on up there.
Or just reality.
That too. Yeah.
You said daily. How can your daily observations and my daily observation be so different? We live on the same hemisphere.
Yeah, well, I mean, I got a lot of stuff going on in my life. I have to start recording these things because I don't know a lot of it. You know, I don't. Yeah,
like the sun, the best thing. Yeah, when you see a Chicago skyline or the refraction, that's just a degree or something over a long surface. That's just about nothing. A 1 degree of refraction, and you have all over the ocean, and you can see Chicago. But still you have that sun 3,000 miles up. You need to bend that 23 degrees down. That's a whole different model.
Maybe.
You need to move the sun 3,000 miles.
50 miles squared came from NASA. I could be wrong. And NASA even says that the Earth is shaped like a pear.
Yeah, so, it is. But you know the difference. You know the difference between circumference from equator to the poles is just 20 miles or something. It's nothing. It's a bit pear-shaped, but not much. It's like 20 miles. It's nothing.
Yeah. Says Neil deGrasse Tyson with no evidence, with no measurement, nothing that could be repeated.
It is. That's that's how they found out it's a pear-shaped by 20 miles, not more than that.
Which experiment?
I don't know. I don't got it.
Well, then why are you saying that it's been done? You don't know what it is.
Just the same you did with that river with 6 miles up the river. You don't do it. You just read about it.
Well, yeah, I don't do it myself, but I can show you the video of the person doing it.
Yeah, you can see now sorry, my English. Neil deGrasse Tyson do it too.
Yeah, but
Videos
Neil
against
deGrasse
videos.
Tyson didn't show the video of the person doing the experiment. He just blabbed it out.
Yeah, but you have, I don't know where to find it, but it's done.
Well, until you can find it, then you don't get to say it, because I'll pull up the guy in the canoe if you want to see it.
How far did they go with that canoe?
To the best of my memory, 5 or 6 miles.
Yeah, then you have a tenth of a degree. 6 miles is a tenth of a degree.
Well, by NASA standards, he should be, whatever it is, 10, 12 feet under the horizon by that point, which, of course, we say is crap. We say is bogus. But
yeah, but then again, if 10 feet isn't that enough for refraction to do? That's small against that 3,000 miles of the sun.
For refraction to go around the curve?
For 5 miles, yeah, no problem.
As long as you can show me an experiment where that's actually happening.
Chicago skyline is 60 miles or something, 50 miles.
You don't get to use the Earth, though. You got to show me an experiment where that's happening elsewhere, where we can see that curving around and still showing us a
boats over the horizon, everywhere, boats over the horizon.
You don't get to use the Earth, though. You got to show me another experiment where we're proving that's actually happening. You can't just keep saying, well, look at this on the Earth. We're saying that's bogus.
That's how daily observations work. You just see.
Right, but then you have to verify that those daily observations are indeed true with an actual experiment.
Yeah, when you have water between you and the boat.
That's not the experiment.
Yes, it is.
Behind you. No, it's some kind of object where we can see light going around that curve. You can't be using the same object we're standing on. We're saying we need to find out if that is actually happening on what we're standing on using something else.
Yeah, and the same with the flat Earth. You need to do an experiment a bit further than 5 miles. Because that's nothing.
There's one where someone did a microwave test or something like that. Let me get it out here for 150 miles. It's like back in the days of dial-up.
Yeah, I remember that.
Oh man, it was torture.
I had a 56K modem and I know what that was.
Hey, it's Nick here. I got an interesting comment on one of my videos about 11 hours ago from a user who calls himself Joe Mama. He writes this: here's a real-world flat Earth proof. Exalt Wireless has a product called Explore Air, which is a line-of-sight microwave transmission platform. I'll put his full comment below the video, but he writes, this product is a line-of-sight microwave link, which is basically a straight line over water, the Mediterranean Sea, to a receiver on the other end about 150 miles away. There should be 3 miles of curvature, but this line-of-sight connection is mounted at less than 50 feet on both ends. He writes, I spoke to them today to confirm this and didn't bring up the reason why. I told them I was just impressed with their accomplishment, wanted to learn more about the equipment and the installation. It is as advertised. A straight line over 235 kilometers of water, that's about 146 miles, point to point, no repeaters. So if you want to check it out, go to www.exaltcom.com.
Okay, let's see if they actually put out, or if this is just nonsense.
This is the website. And then I found the original article that the gentleman posted about.
Looks like they don't have. Well, let's see. I was afraid of that.
Hmm.
And I'm like you. I don't trust these guys if they don't have the actual experiment to put out. So let's find out. All right, I'm gonna give you about 10 more seconds. Let's do this. Damn.
I know how it is. Every time you wait for something, it takes longer time. That's typical. Like me
Yeah.
before with that computer just denying everything.
Well, all that's doing its thing. So,
I know.
and I haven't been in the military, but there's a handful of testimony online, and it could be bogus, but there's guys who say that they do kind of like, naval targeting equipment, for weapons and stuff, and they say it's all based on line of sight, over a large, distance, and then you have surveyors. There's a guy with $100,000 challenge who's a surveyor who wants to do who's challenging Myrtle Beach, which in the U.S. is the longest public beach, and I think it's 60 or 70 miles or something like that.
Yeah.
And from what I understand, there's a lot of people on, surveyors on, and by a lot, I mean I've seen maybe 3 or 4, of surveyors on YouTube that say that there's no account for curvature at all.
You have this one guy, he has a flat earth believer who was on, I don't recall if it was that beach, beach, but he filmed a video, and there was a hotel, and when you get further away from the hotel, half the building disappeared in the ocean. Sorry. So behind the curvature, he from one point, and he backed off further and further away, and then the hotel disappeared behind the curvature from that beach.
Right. So then my question remains, why does that seem to be less prominent the higher you get? At least the 20 miles high from the high altitude balloon flights that I see, that look pretty damn flat.
Yeah, but he was at the beach. He was observer height at 3 or 4 feet or something, and then the hotel disappears. Half
and there's a guy,
half the height of the hotel disappears behind the curvature.
Right. And there's a phenomenon too with flat surfaces where, you heard of Nathan Thompson?
Yeah, he has been debunked so many times.
Who's what?
He has been debunked so many times.
Perhaps so. Let's see. The other one is still loading up. I don't think we're going to have any luck there. There's one that he did with a book, like on his kitchen floor, and showed how the book disappeared, even though the floor was.
You know what you know what causes that? You take a camera, and it plays.
It's an issue of.
Is the issue of. Let me see here.
Oh my gosh. Can't even find his. There we go. At least I found his channel. Oh, this Exalt whatever website's taking forever. I'm just going to close that off. Oh my God, it's taking so long. There was a book on the floor, it disappeared. One more minute here.
I can explain how it works while you find it.
Yeah, never mind. I'm not finding it right now. Just go for it.
When you have a camera and you place it on the floor, you have the floor down here, and you zoom in at something way over there. The first bit here gets out of focus, and that out of focus part, whatever it is on the floor, you get that layer of diffusion. That's how it works. Whatever is flat down here will be out of focus, and you mess up. So whatever it is, flat or not, everything in here seems like it raises because you have out of focus.
All right. That might be true. Let me see. That guy, Red Pill Philosophy, he did a test that didn't require the camera being on the floor. He taped a piece of string to his camera. And let me see if I can find that for you. Come on now. Computer's waiting out. Let's see. I wish I had a better memory and I could just memorize the name of all the videos.
I know. There's lots of videos to find out. I know it. Yeah.
This might be it. Oh, crap.
Look here. Let me tell you something. You better come on now.
Okay, guys, we are back now for a second version of essentially the same experiment. This time, however, we're going to mess around with the obstruction. Last time, the obstruction was above the camera's eye level. This time, we're going to put the obstruction at the eye level, as close as I can get it, because it's a precise thing, and below the eye level of the camera. First and foremost, we are nice and level here. In addition, we're also about the same distance away. So this is the same setup from the first experiment. There's this little black button here, and keep an eye on this white box. And when I press the button, it recenters it. So I'm going to use this white box as the guide so that as I lower the height of this obstruction, I'll be able to determine whether or not it's equal to, above, or below the center line of the camera. And so for the first experiment, I'm going to lower the obstruction so that it is beneath the camera's eye level. Okay, so as you can see, without a doubt, it is below the center point of the camera eye level. So we're going to go ahead and recreate that same experiment from the prior video. Okay, so at the start, with the bottle right up close against the obstruction, you can see it is at the 2-inch plus 15-digit mark. There's 16 of these tiny little lines in every inch. So it's at the 2-inch plus 15-digit mark. As it moves back a little further away, now it is at the 2-inch plus 9-digit mark. And by the time I moved it back all the way to the end, it is at the 1-inch plus 14-digit mark. And this is exactly what you would expect if the obstruction was a little bit below the eye level. As you move the bottle back, the camera will be able to see further down, above and down the obstruction to reveal more of the bottom of the bottle as the bottle moves back. And so now, just like the last video I did, now we're going to go ahead and pull out the string, tape it to the very center of the camera eye lens, and stretch it out and see if the string, the direct line of sight, lands exactly where the camera's perspective line of sight showed the cutoff point. Okay, so when I stretch the string out in a perfect straight line from the camera, just nipping the obstruction,
and then placing it straight to the ruler, the string landed at the 2-inch plus 10-digit mark. So again, just like last time, we have ourselves a discrepancy between where the straight line string lands and where the camera's perspective point of view showed the cutoff point. The cutoff point for the camera was 1-inch plus 14-digit mark, and the straight string landed at 2-inch plus the 10-digit mark. You can see the discrepancy.
Okay, so now I'm going to attempt to perform the same experiment, but I want the obstruction in the middle to be as closely precise to this camera's eye level as possible. That real perfect horizontal mark. And again, this little white square on the camera, we'll be using this as the guide to determine the most level center. So the idea, of course, is to get this obstruction right here, raise it up to the very center, and let's do that.
Okay, so it took multiple tries. I was literally inserting like individual credit cards and gift cards onto the stack. It's just incrementally raise the obstruction up little by little. And every time I raise it up a little bit more, it's almost enough, but still not precisely at the camera's eye level until finally I got the exact point so that the obstruction was so precisely eye level that no matter how far away the bottle and the ruler was, or no matter how close it was, you got virtually no change in how much of the bottle ruler you can see, no matter how far away or close it was. Of course, now the big question is, when you're standing on a sphere Earth, and you're looking at the obstruction, bulge, horizon, whatever the hell you want to call it, that's obscuring something like a lighthouse in the distance, the question now is the obstruction bulge directly at your eye level? Or is it above your eye level? Or is it below your eye level? I've heard conflicting answers. Originally, I thought that since it's an obstruction blocking your line of sight, it would probably be above your eye level. But after a few people told me otherwise, I'm thinking, yeah, it kind of makes sense that the bulge would be below your eye level. But I definitely do not think the bulge obstruction is at your eye level. That doesn't make any sense to me. But yes, because you're standing on a sphere, it's descending down beneath you. It seems to make sense to me that you have to look down to see the edge bulge in the distance. And on the results so far, when the obstruction is below the eye level, we pretty much got the same results as when it was above. There was a discrepancy. But again, this is the whole point that I think still needs to be fleshed out, and I'm still not fully crystallized on it yet. Okay, so then as always, I pulled out the piece of string, taped it to the camera eye level, stretched the piece of string across, but now here, something kind of interesting happened. When I pulled the string across and I placed it on the ruler so that it was at the 4-inch plus 3-digit mark, which was the cutoff point according to the camera, when I stretched the string across, there was a slight bent in the string. Now, since the obstruction was set pretty much at eye level, and the bottle was moved forward and back, and there was almost no change. There was only a change by like 1 digit between when the bottle was really close and when the bottle was far away, indicating that the obstruction was pretty close to eye level, just off by a little bit. When I pulled the string across, as you can see, there's a pretty significant bent in the string, and I would have expected it to have been basically straight. That's what you would have expected. There's a few possible reasons for this. One possible reason that because the string is thick, for it to run totally flat, it would have to. So it would almost be like if you had to cut the string in half, so it could actually just cut right halfway through the top surface of the obstruction and truly kind of lay flat on there. It's also possible that that tiny little 1-digit difference between when the bottle was close and far away, maybe that's what's causing it. But it is a pretty significant bent. I mean, if you put a straight line up against it, it's a pretty significant bent. So again,
I saw it, but I don't know what it's supposed to prove.
Yeah, sorry for wasting your time. That wasn't the one I was thinking of, and it's late and I can't think right now. So I'm sorry. You'll have to forgive me for droning on that video for a while. I thought it was going to go somewhere. Anyway, well, anything else on your mind?
I just still don't think how people can believe in a flat Earth with all the daily observations pointing at the sphere.
Just a few of that off the top of my head. And I know we didn't really get very far today, but I'm just kind of talking and discussing anyway. But as I understand it, our bodies can feel velocity, or our bodies can't feel it, velocity, but we can feel the change in acceleration.
Yeah.
And if the Earth is spinning around the sun in an elliptical pattern, there would be several places on there that we would be able to feel that change in acceleration, even if it's very slight.
No, because that slight, you say, that's over a period of time, and it's no, it's smooth and very, very durable acceleration over a long time.
Yeah, but we're talking about some pretty fast speeds and some pretty big changes. In a car, if you're going 50 miles an hour and you change it to 51, you can feel that.
Not if you use 15 minutes or an hour to do it. You have to scale it down.
Yeah,
Everything is scaled down from, when you scale from universal size down to a car, you also need to scale down time.
I would say you can feel very slight changes. I mean,
I had one guy who said he was driving around a racetrack and you feel the turns. Yeah, at 1,000 miles an hour you do, but do that turn in 1 year. Do that lap in 1 year, you won't feel a thing. If you go
you
around
will
one,
if you change your speed by 1/10 of a mile an hour, you'll feel it.
I don't think so. If you use 1 hour, no, sorry, 1 year to go around a racetrack, you don't feel anything.
Well,
1 year. You have to scale down. When you scale down from universal size to a car, you also need to scale down the time. You cannot say the Earth spins at 1,000 miles per hour. You can't take a tennis ball and spin it at 1,000 miles an hour. You spin a tennis ball once every 24 hours. That's the speed.
Yeah, but I'm not talking about the Earth spinning around. I'm talking about the Earth moving through space. There are times when you're changing a lot of speed in a short period of time, like only a few hours to go from one speed to a very different speed. Because an elliptical pattern has 4 distinct points where it's speeding up and slowing down to whip around that side. And then there's a very long period where not much is happening, and then you'll have another moment where it's kind of getting that kind of cracking of a whip kind of effect.
Yeah, but then again, have you scaled it down and tested it on yourself? Have you scaled down the size, the time, the acceleration, everything, and then did a test on it?
Have I scaled down the time and everything?
Yeah, you need to scale down everything.
No,
yeah.
I guess not.
Yeah.
But it just seems a little strange to me that, there would be some moments where there would definitely be changing and we feel no difference at all.
Yeah, but that's daily observations. And if you say, I need to have these experiments to show the Earth this curvature, you have to find an experiment that show you how you can feel that acceleration.
Well, when I'm in a car, and someone brings slowly, even only 1 mile an hour, you can feel those very minute changes. Every cell in your body is designed to feel those very, very small changes. That's part of our survival mechanism.
Over how long time would that 1 mile an hour be?
Huh?
Over how long time would that 1 mile an hour be? From 51
over an hour.
From 50 to 51, or from 100 to 101 over an hour? Would you feel that?
If at least the very first initial change, yes.
No, we're talking about scaling everything, not from 50 to 50.8 and then to 51, but all that from 50 to 51 over 1 hour. You wouldn't feel that.
At least the first second, you would, yes.
Because a car is a combustion engine, and you had that jerk. You don't have that on the Earth.
Even without the jerk, your cells are designed to pick up on those very minute changes.
Over an hour, 1 mile an hour difference on 1 hour.
At least the initial change, yes.
Because the car is a combustion engine, you have that jerk. You don't have that.
Even if it wasn't in a car, it was on a bike or inside something else.
But as you said, you have to experiment or scale it down to correct size, correct speed, correct acceleration over the correct time, and everything. That's need to be experimented on.
Yeah, that's true. Yeah, I haven't done it. I just have been told that we can't feel velocity, but we can feel a change in acceleration.
Yeah, because when you're on a plane and you travel at 500 miles an hour, you can still walk up and down the aisle without feeling it. You can still turn at 1 degree per 15, is it half a degree per minute, and then still don't feel it. Yeah, that's how the Earth moves. And that slight over time acceleration you're talking about, you have to scale it down, everything.
It's possible that could be it, but that's not how I understand it. I understand the body to be kind of a very high functioning machine. and that it should be able to pick up on those little things. And it seems to make sense to me.
We're not Superman.
Well, no, I didn't suggest that, but we are very, very highly complex machines.
Yeah, sure. Not denying that.
Yeah. And I mean, also on the issue of the plane, when people talk about moving from east to west and then west to east and having it be the same time travel, from one city to the next, it's also very unusual.
There is a slight difference because of the rotation, but not that much. Yeah.
Well, there wouldn't be a slight difference if you're traveling 400 miles an hour the opposite way.
The Earth is spinning once 24 hours, and a flight may take 4 or 5 hours, so it doesn't move that far.
Right, but if you're going this way with the Earth, and then you're going that way with the Earth, that would be a big difference.
There is a difference, yeah.
Like not just a half hour or so in a flight, it would be like 20 minutes to go from. I'm just pulling these numbers out of my rear, but to go from LA to New York would be 20 minutes as opposed to the other way, or whichever way it's. I don't know. I don't have my bearings straight right now. Hopefully the Earth's turning, but you get the idea.
Flights on the northern hemisphere is on the flat Earth model is not that bad, but how about when you travel from Australia to South Africa or South Africa to South America? Then you have to, 747 has a maximum flight time of 14 or 16 hours or something. And they do that on the globe from South America to, where is it? South Africa? I don't remember. There is flights. But on the flat Earth model, that flight would take twice the time, or the plane would travel twice as fast. How would that be?
Yeah, I think we're talking about two different problems here. On the globe, what's the excuse for the flight not being super fast when you're going against the turning of the Earth?
Because that's not big a difference. That's when they travel east to west on the globe, that's not much difference. There is a difference, yeah, but not that much. It's what should it be?
If you're going 500 miles an hour one direction while the Earth is traveling 700 miles underneath you?
We are moving 500 miles in relative to the Earth, yes. In relative to the Earth.
Then what's the explanation for the Coriolis effect, where they claim that snipers have to make adjustments for the Earth turning with a bullet going through the air, but not for a plane going through the air?
What's the difference between the bullet and the plane?
Well, the bullet is a little faster.
The bullet doesn't have engines or steering equipment. The plane has.
So what?
The plane steers. The plane adjusts. A bullet doesn't.
Yeah, but a plane going, in one direction, basically, I mean, it'll make some turns here and there, but basically,
yeah,
but a sniper bullet going through the air, they say you have to make the adjustment because of the speed of the Earth turning.
Planes do that too, but planes have rudders and flaps and engines. A bullet doesn't have that. A plane can adjust. Okay. A bullet can't.
So you're saying if a plane does decide to go in a perfectly straight path, then it will reach the next city in 30 minutes instead of 6 hours?
The greater circle path, yeah. That's when you're going from Norway to America, almost over Iceland or Greenland, not in a straight line, but it looks like a curve because it follows the greater circle on the globe.
Yeah, but the plane is never tipping its nose down to keep going around the Earth.
The gyros are self-adjustable. Ask any pilot. The gyros are self-adjustable.
So what? It's not tipping its nose down to go around the Earth.
It doesn't need to.
So that the gyros are self-adjustable?
Yeah, self-adjusting, yeah.
What do you mean? So the plane doesn't have to tip them?
Do you know the laws of a flight? You have drag, you have lift, you have thrust, and you have gravity. When you have those four, you don't need it, because when you fly around the globe, it's the same over everywhere. So it just follows. You don't
Okay.
you don't get any higher because you're in that layer of air. You are at 40,000 feet or 30,000 feet, 1,000 feet. You stay that way, and as long as the gyros
Say
are
you actually have
self-adjusting,
to put the nose a few degrees higher to keep
sorry,
it in the air.
what do you
They
say?
say actually you need to put the nose a few degrees, about 3 degrees up to
No,
keep it in the air. That's what the pilots say.
that's the law of physics of the plane. It's just you set it at that altitude, and that altitude is the same altitude all over. So you just follow.
Yeah, so is the bullet going around the Earth also?
Yeah, but not that far. What's
No,
the
the
maximum
bullet-
range of a bullet? Is it 2-3 miles or something?
Yeah, something like that.
Yeah,
But the bullet's not going around the Earth the same way the plane's going around the Earth.
because the bullet doesn't have engines.
Right, so the bullet is going straight. The plane is going straight
Mm.
for the most part, right? Because the Earth is so big, it might as well be, considered a flat plane. So why does the plane not have to worry about that issue of the Earth going against it?
It does,
the
but it
bullet has
adjusts.
to?
It adjusts. It has the ability to adjust. Bullets don't have that. Bullets go straight.
Yeah,
You give it a speed, and it goes that way.
I mean, that's a big adjustment to go from a 6-hour flight to 20 minutes.
6-hour flight.
From New York to LA,
Yeah.
Which would be much, much, much faster than LA to New York.
No.
I mean, we're talking like a huge difference because you have, a 500-mile-an-hour plane going against a 700-mile-an-hour surface.
It's still in relative to the Earth. The airspeed is relative to the Earth.
Okay.
The air
Can you
moves
show
with
us
the
that?
Earth.
The air moves with the Earth, so gravity not only is sucking everything down to the center, it's also keeping everything where it belongs as it's going around.
Yep.
Do we have an experiment that shows that happening without having to use the Earth?
How can you do that? How can you scale down gravity? We live on the biggest mass of gravity there is. You cannot scale down gravity in other way than that two balls hanging experiment. I don't remember the name of it. But
Cavendish, which is
Cavendish, yeah.
already.
But you cannot scale down the Earth to test gravity. There's no way to do that.
Well, apparently you can, because gravity exists in all kinds of different levels. It exists with the Earth to the moon, and then both the Earth and the moon to the sun, and the sun to the center of the galaxy. So it apparently has.
These two have a
just as
field
much-
of gravity on their own. They don't suck to each other because you have the gravity down here. That's much, much bigger. So you cannot scale down gravity to test it. There's no way to do it. That's impossible.
Well, then why does it work from the Earth to the moon, and then the Earth to the sun, and then the sun to the center of the galaxy?
Yeah, but how would you test
It's
it?
all just another
There's no way to
model.
test it.
You have to test what?
Gravity. There's no you can't explain. You cannot experiment on gravity without that Cavendish experiment, because we live on the biggest mass of gravity there is. You cannot scale everything down to test it.
Apparently, it's not relevant if gravity still works between the Earth and the moon, and then the Earth to the sun, and then the sun to the center of the galaxy. It should just exist on any other microscopic level as it does macroscopic.
Yeah.
Not to mention the issues with the moon. I mean, I'd like to see the explanation for how the moon has its unique sense of gravity where we only see one side. And I mean, does anyone have an explanation for that?
Gravity. But
saying
again,
gravity doesn't explain anything.
How do you explain? How do you explain the flat Earth model and with the sun and the moon traveling 3,000 miles up in a circle? What steers it? What keeps it in a constant right turn? What accelerated? What accelerated from the center at 1,200 miles an hour to 2,000 miles an hour at the Capricorn? There's an acceleration and a deceleration.
Well, my claim is that no one knows.
And still I believe it. You believe in something that people don't know.
Yeah.
Yeah.
That's the way science works. I'm not so much saying I believe it. I'm just saying that there's no explanation for it. And I don't believe people who say that they know who can't give me the experiment that shows how it's working.
How does solar
panels?
It
could be some kind of electromagnetism or, I mean, until we go to the all the areas of the Earth and get to check it out ourselves, we're really not going to get close. We can only base our at least base it on the oldest text document that we have, and
we have solar panels all over the world. How would that be on a flat Earth model sun? Is it 30 miles wide or something? What would power those solar panels all over the world? We have solar heat plants. Those are big, let's collect the heat from the sun and shoots it up to one tower to heat up the water. How would that work on a flat Earth sun?
I'm sure we come up with all kinds of clever ways of capitalizing on the stuff that's there without fully understanding what it is and what it's doing.
Oh, people understand it, but some people don't.
Okay. Well, the sun's 90 million miles away, right?
Yeah.
What is the experiment that measured that claim?
Parallax.
Okay. Explain.
You have the sun, you have the Earth here, and you have half a year later the Earth here, and you measured it through Venus or something. I'm no mathematician, so I don't know.
Exactly. Nobody does.
It's done.
Well, show me.
The experiment is done so many times. It's all over internet. My computer is overheating. It's there. It's just look it up. But then again, if you say
this is because everyone just says parallax or they say radar, and I'm like, okay.
You say microwave over the ocean. So where's the difference?
Well, I was hoping to pull up the website where it was going to show the actual experiment, but I'm sort of limited with the same problem you have, so we'll have to try again later when our computers are working or whatnot. But when I say, like, for example, I got a buddy of mine that says, well, they do it with radar, and I say, well, what do? They point a cop's radar gun at the sun, and he came back saying 90 million miles, or like, show me the experiment where it was working. Whatever they're doing, there's no fully detailed, complete experiment that's actually showing how it was done.
How can the sun be small and local if we have solar panels all over the world and solar heat plants and all that?
Again, I'm sure we're clever enough to think of all kinds of ways of capitalizing on the resources that we have here, with different tools and stuff that we can make up.
Like a big sun.
Doesn't mean that's where the sun is and what it's doing and what it's made out of.
It's a nuclear bomb. It's a big nuclear bomb.
Maybe. But no one has shown me how yet. All I see it now is in just, in a few textbooks in government schools and, some NOVA specials on TV.
And then we have daily observations.
The distance to the sun.
And then we have daily observations that tell us the sun is not local and small.
But looking at a couple of points of light in the sky is not measuring.
Exactly.
You can
when you see those crepuscular rays people that say you have the triangle from the Earth to the clouds and you have the sun there, that's perspective, and that's not the way of telling the sun is small and local.
Yeah, I agree. There's no measurement that we have yet that shows how far the sun
Parallax.
Is.
Measuring through Mars or Venus or something.
That only works if you make the assumption of how far away the Mars or Venus is in the first place.
Or you have the angular sizes of them and use mathematics, which I'm not expert in any way.
Yeah, but
scientists
of that will
do
come
this.
down to proportion. You can get a million different answers based on how far you assume one of those points is.
Scientists do this. I'm not a scientist.
Right, but the scientists aren't doing the measuring; they're just doing the calculating.
Yeah.
You have to at least have one measured, one verified, confirmed point that you have measured for parallax to work.
Again, I'm not a mathematician or a scientist, so I don't know, but it's done many times.
Right. So I get people who say, well, it's parallax. And I say, well, show me.
You have finger in front of your eyes, you close one eye and the other eye, and things move. That's how you do it.
Yeah, no, I know what parallax is. I'm saying show me the experiment that they used parallax for that verified the distance.
I could use Google, but so could you. It's all over.
I have, and there's no one that has the experiment that shows that verified that they measured the distance.
Then you're searching in the wrong place. But then again, you have internet, you have YouTube, you have Google, and still you choose to believe in something that's not verifiable in any way. How can that be?
As I just explained, I've looked all these things up, and no one is showing me the experiment. No one is posting the experiment that shows that they've verified the distance to these points. They're all just showing numbers that with assumptions on the first initial point that they make.
I'm not sure about that. Yeah.
Yeah. And the people who are saying that it's parallax don't have the experiment that shows the verified distance. All they have are the same things that I've seen that are just people with numbers that they assumed certain distances were.
Yeah.
Which may still be true. I'm not saying that it's not true. I'm just saying it's not science. Science requires measurement and requires verification and repeatability.
Isn't everything about a flat Earth model just assuming anything? There's no...
Not the stuff where they're taking video of people rowing away in a canoe and they can still see them.
Yeah, but when you have the...
I'm not saying that those are right either. I'm just saying that is at least science.
Let's go back to south. Yeah, let's go back to the south of the Tropic of Capricorn. When you have... I could pull up that SketchUp again, but then my computer would deny it. South of Capricorn, you have the Earth, the Sun moving in a horseshoe-like shape. It comes up in the north and goes in a horseshoe and goes back on itself twice and go back. That doesn't happen on Earth. We can measure the Sun moving 15 degrees an hour everywhere, from anywhere. And you can do it, I can do it, anyone can do it. The Sun moves 15 degrees every hour. South of the Tropic of Capricorn on the flat Earth model, that is just doesn't happen. It goes back on itself twice and not ever coming over to the right hemisphere. Because in the South Africa...
I've never been in the Southern Hemisphere, but so you're saying if you look at it, it goes like this?
Yeah, but just the opposite. It goes from your point. If I look at you, it goes from here and goes towards you and then back away from you. In a horseshoe shape, and that doesn't happen south.
That sounds like it's what it would do on the Southern Hemisphere. If I'm standing south of the Tropic of Capricorn, right?
Mm.
Wouldn't you watch it come at you like this and then go like that?
Let me just test one more time if SketchUp can work with me here. I'm going to challenge my computer one more time. Or not. But
hold that thought. No luck.
But everywhere from on Earth, you can see the Sun move 15 degrees every hour. That's not anything you can deny. That's how solar solar clocks or sundials, they work at 15 degrees every hour. That from anywhere on Earth except from the North Pole, that doesn't work on the flat Earth model.
I don't know. To me, it seems like the sundial would work a lot better on a flat Earth than a globe Earth.
No, because when you're on the North Pole on the flat Earth, you have the sun going around in a circle. If you move that point to close to that, you don't get that 15 degrees per hour, and it goes in an elliptical shape.
I mean, I'd have to see it. But we don't
Let me just get 2 seconds, a good paper. And a pen. Like this. So there's the flat Earth model with North Pole, and you have the sun going around. If you are out there on the side, here, you don't have 15 degrees per hour movement of the sun anywhere. That's pure geometry.
If that's what's happening upstairs, yeah.
If you live outside the Tropic of Capricorn where the sun moves, down here, the sun goes in a horseshoe shape. That's not 15 degrees per hour.
Well, we'll have to do some experiments. We'll have to find people who have done time-lapse of the sun in the southern hemisphere and measure it out.
Sundials have worked on the entire globe for 3,000 years because of 15 degrees per hour.
Maybe.
That's not maybe, that's facts. That's undeniable facts. You cannot deny that. The sundial has been used for 3,500 years.
Have you checked?
That's a fact. Sundials.
I didn't know that was my question. Have you checked?
No, but I haven't lived for 3,500 years, and I'm not that old.
No, I'm talking about, have you gone to all these places and checked, or do you have someone who has?
I haven't been south of the Tropic of Capricorn. I have been at the equator.
Did you check with a sundial?
No, but you don't need to, because it doesn't fit.
I was just curious. I want to know, because I haven't either. I'm not claiming to have. I was just wondering. I need to check.
That's how equatorial mounts work on telescopes. They also depend on 15 degrees per hour, and that doesn't fit a flat Earth.
Give me just a minute here. I have one file saving here before I load up another one. If you don't mind waiting there just for a minute, I'll be right back. I was anticipating you were going to take a little longer getting your paper and pencil and writing it down, so I saved a file. It's still going here. It says it's got less than a minute. But
if you see here, back to that, you have South America here. You have sunrise and the sunset. In the summer, it's about 17 hours or something. Then the sun needs to move in this shape, and you observe the sun only over here. And that's not how it works on any reality.
Yeah. I've heard of that. I have yet to find someone that shows it. But not that I'm saying I think it's wrong, but I have a buddy who's going there, I think in April, to record a time lapse of the sun over 17 hours. So yeah.
And people are living at the equator. In the summertime, they would see the sun at 2,000 miles an hour going over there. In the winter, it goes 1,200 miles an hour over there, and the same distance. 1,200 miles an hour, 2,000 miles an hour. Do you think that's reality? I don't.
Again, it's very mysterious.
Not
very
really.
Mysterious what's going on, but
it's not mysterious. Yeah. It fits the global Earth model perfectly.
You have the issue with the sun. I'm sorry, I'm just watching my thing finally get done here. Come on, man. Let's just finish this up. Not you. I'm talking to my computer.
Ah, it's okay.
It's like the whole status bar is right at the end. It won't do that last little part. It's driving me crazy.
It was that previous year when you sent me the other link and was loading Google that mail thing, Gmail. It was 99%, and it's we cannot connect to Google.
Okay, that looks like it's done there. Oh man. Okay. We're back in business now. Yeah, what's going on in the skies is too complex for me to put all together right now. That's what I'm trying to do.
But the sky is the best place to look.
I would disagree. I would say for flat Earth or round Earth, the better place to look would be at the Earth. But you can't discount what's going on in the skies. So it's not when we're not going to get answers, I don't think, until all of us work together and start doing some experiments and posting them, and little by little over the next few years, I'm sure it's all going to happen.
You have amateur astronomers all over the globe doing experiments with equatorial amounts on telescopes, and those only work at 15 degrees per hour and in one axis. So that doesn't happen on the flat Earth. I used one 3 or 4 years ago. I used an equatorial amount a friend of mine had, and that follows the stars in one single path. On a globe, on a flat Earth model, the stars move around and you need to follow twice in two axes. That doesn't happen.
Right. My couple questions there, what I have is apparently Polaris is off anyway because of this refraction issue. So if they're pointing it in the wrong spot in the sky in the first place, I mean,
how much refraction do we have looking up?
I don't know, but that we're told, with the globe model scientific stuff, that the stars that we're seeing aren't actually there.
Refraction is caused by temperature variance over the water. With air and water, you get a layer of refraction over the water.
Whatever the term might be, then with the light of the stars penetrating through the Earth's atmosphere.
Yeah, but that's minuscule.
Apparently not. I mean, they say it's at least a few degrees.
But then again, that wouldn't explain how on the flat Earth model you need to bend it 90 degrees, not a few degrees, but 90.
Unless it has something to do with perspective or something else going on up in the sky, or it might have something with the way that we all see the stars individually in a certain way. I mean, who knows?
Oh, light doesn't bend. Actually, you said that yourself. Light doesn't bend.
Why it doesn't matter?
Light doesn't bend.
Yeah, I don't know.
You said it yourself that we have no experiments that show that lights bend.
Yeah.
So if you see if I see Polaris at 60 degrees and you see Polaris at 45 degrees, where is it? Where do we see it?
I don't know. Maybe we all have an individual experience of what we see in the skies.
Then we live in the Matrix.
Or very close to it, almost in a creation that was specifically designed for us.
Then what control do we have of other experiments?
I don't know. We can try the best we can.
Yeah.
We can try the best we can to put it together.
Then you dig yourself down in a hole.
We're never going to come even close to understanding the incalculable complexity of this world. Everyone knows that.
But if you don't believe your own eyes, if you trust in others, and then you say we don't have control over anything, you dig yourself a hole. You just
ding, ding, ding. You got it.
You need to trust your own eyes. Daily experiment, daily observations.
Your own eyes deceive you all the time. There's all kinds of fun little kid games that you can get where it shows how your own eyes don't even work. So it's an unfortunate fact of life.
But then again, we didn't have that technology 400, 3,000 years ago.
What, little kid game cards with the optical illusions and stuff?
Yeah.
Sure.
And the Earth hasn't changed since then.
Right.
So why should we see then the difference?
I'm just saying that at one point you got to have faith. at one point you have to realize that we're not going to ever come even close to figuring out the incalculable
Oh.
sophistication of the world.
Fate doesn't have anything to do with geometry. This is flat or sphere. This is a simple question of geometry. Flat or sphere. As simple as it gets.
You asked, like, something a few minutes ago about, you know, how we're going to figure out everything here from the inside in some kind of matrix-ish sort of world, and we're not ever going to get close to figuring it all out. That's
Not
why
everything,
I'm saying,
of course, not everything, but
yeah, I'm saying like even a small portion, like no one knows what's going on up there is my claim.
most people do. Not everything,
they say
but
they do.
Not everything that happens, but much, yeah, very much, yeah.
They say they do, but most people, in fact, I would say every person that I've met keeps saying, well, scientists have done, and then insert in blank, you know.
How much do you really need to know? We know how the sun moves, we know how the moon moves, we know how the stars move. We don't need to know everything about it. We just need to know how it moves. How it
we
moves.
Don't even know the distance.
Yes, they do. But with
we
parallax.
Don't know the base. No, that's not. Motion parallax is not giving you the distance to it. It's just,
Again,
it's
I'm
just
not
giving you sort of.
I'm not a mathematician or a scientist. I know it's
exactly.
done, but yeah.
That's the problem I fall into with every person that I meet. Is they say, well, we know because of motion parallax, and then they always say, but I'm not a mathematician or a scientist, and that's what I'm trying to tell people. I know no one seems to be that person, that elusive, magical person that knows the actual answer with the actual guts and the actual measurements and the actual data that can be repeated and verified.
You don't need to be actual or accurate. You need to know that when it stands on the equator, at the equinox or equinox, the sun moves in a straight line over you, but it doesn't do that on a flat Earth model.
Okay.
Because the sun never moves in a straight line; it moves in a curve, always in a curve.
The model is correct.
But how would you get a straight line shadow from a flat Earth model sun?
Don't know, and I don't think anyone does.
Because it's not doesn't happen like that.
Well,
as long as the Earth is a spinning sphere, everything matches the daily observation of the sun and the moon and the stars, and it doesn't happen on the flat Earth model.
If the Earth is tilted and the sun is to the side of the Earth,
yeah.
Why would the sun be going straight over the head? Wouldn't the sun be over here? If the Earth is going like this,
yeah.
How could it be that there would be a straight line going across? Wouldn't the Earth have to be straight up and down, turning this way for the sun to go straight across?
I'm not sure where you're going. It's 23.4 degrees.
Yeah, let's put the Earth at 90 degrees up. Pretend there's no tilt.
Yeah.
So the equator is right in the middle, and the sun is right to the side. That's when it would go straight up and down over you, right?
On the equator, yes.
And there would be a direct line.
On the equator, yes, yeah.
But the Earth is like this.
Yeah.
So the equator is going sideways.
Yep.
But the sun is still over here on the side.
Yeah.
So
but
how would it be going?
On the equinox, it's on the side. Spins that way. Then you have 90 degrees.
But the equator is never facing toward the sun.
Yeah, on equinox. Summer equinox, and also what do you call it in the March, 21st of March and 21st of September? Isn't that equinox?
Well, I'm not sure, but isn't the equator always going this way?
Yeah, but when it tilts like this, you have from you and towards you and from side to side that way.
Wherever you put it, it's never pointing towards the sun.
Yeah, at equinox, on the side.
No, it's always tilted.
Yeah, but the tilt doesn't go like this. Wait a minute. I take this one. This one is better. This is north, and it tilts that way. Here is away from you. Here is towards you. But here and here is right at that way.
But it's still going that way. The equator is still going sideways.
Yeah.
No matter where you put it, it's never
this is
pointed toward the sun.
Summer solstice at northern hemisphere and winter solstice at the northern hemisphere. This is a spring equinox. This is spring fall equinox. Then you have it from side to side.
Yeah.
Then
So
it's
you have to tilt it at 90 degrees for that equator to be facing toward the sun for the sun to go directly over.
all the year, yeah, all the year, but not at equinoxes. Then it's on the side.
It just seems strange. There's never a time where you would look straight up and see the sun go up over you like that.
At equinox. Only at
But
equinox.
You're still facing that way, isn't it?
No, that's in the summer.
But then this way.
That's in the winter.
Okay. Then the sun's still to the side.
Yeah, but if directly from me to your arm, that way. 90 degrees that way. Not this way,
Like that?
that way.
Yeah. You would still see the sun go sideways.
No, then it goes straight over your head. At equinox, at equator, at equinox, it goes straight over your head in a straight line.
Okay. I got to work that out later on because I'm still not seeing. Well, I'll have to just be sitting in the same room, or I'll have to sit in the same room with someone else and do it.
You have the Quinto or something sundial in Ecuador. You have the Quinto sundial exactly at the equator. Then you see the shadow moves in a straight line at equinox. That doesn't happen on the flat Earth sun because this flat Earth sun always move in a circle.
Yeah. On the model, yeah.
Yeah, but anyway, if you have a flat Earth, any model, not any model, how would the sun move to make a straight line? I have seen one model where they have the Pac-Man sun where it goes over and it disappears and it pops over to the other side like a Pac-Man. And I see one where they have one North Pole and 3 South Poles spread all over, and the sun going like that because of Why not just accept that the Earth is a globe and everything fits? I don't understand it.
Because there's no explanation for why people aren't falling off from the bottom.
Gravity.
And here's another one, like a compass, for example. When you're in Australia and your compass is pointing north, are you pointing through the Earth towards north, or is it pointing around the Earth towards north, or
because
is it outward?
On the southern hemisphere you have other compasses. Compasses on the northern hemisphere doesn't work on the southern hemisphere.
Have you tried this out?
As I said, I haven't been south of the equator. But this is how the magnetic field looks. And the compass doesn't point towards North Pole. It follows the shape of the magnetic field.
So you have to point it out towards the sky?
No, you have flat. Just keep it flat. And it points because it follows the magnetic field.
And that magnetic field just kind of pulls it up toward the north?
Yeah.
Do you have an example through experiment of this happening without having to use the Earth?
How could you? Magnet?
Yeah.
But why is gravity such a mystical force? It's just like magnetism.
It's literally a theory.
And the force.
No. There's a theory of the force of gravity.
But what's the difference between gravity and magnetism? Why is magnetism accepted when gravity is not?
Because magnetism isn't a theory.
It's the same force, almost the same force, almost exactly the same.
Almost isn't science.
You have small magnets, you have small force. You have bigger magnets, you have bigger force. The bigger magnets, the bigger force, exactly the same as gravity. You have the Earth is a big piece of mass, and you have gravity.
Yeah, the gravitation is not the same thing as magnets, magnetivity.
It does the same. It's
Because it has a magnetic field doesn't mean that gravity is the same as magnetivity.
It's not exactly the same. It behaves in the same way.
Okay, it's still a theory, and magnetics are not.
But what causes this then? Why does it fall down?
I mean, because things appear to fall. If
Why?
something is heavier than the medium it's in, I don't know. I didn't create the program.
Some people say we have density and buoyancy. If you take
Seems to play a part.
if you take a ball and push it down in water, it goes up because then water is denser at the bottom than in the top. If you go scuba diving, I've been scuba instructor for many years. If you go scuba diving, you go to 10 meters, you have to double the pressure as you have up here because buoyancy and density. The air is about 800 times less dense than water, but it behaves in the same way. The air is less dense up here than it is down here. Just drive up a mountain and you feel the airs pop. That's the simple experiment on that one. You go up a mountain or down a mountain, the airs pop. That's the experiment. You have felt that yourself, yeah. So the air is less dense here than here. So if I drop this pen, it should go to a less denser area, which is here. But it doesn't. This is density and buoyancy. This is density and buoyancy. This is gravity.
Or it could just be that there's, some kind of running program that says things that are heavier than the medium it's in will go down.
Because of gravity. Running program.
Maybe.
You're in the matrix again.
Not suggesting that. It just could be one of the elements of life. Could be something that we just deal with.
Like gravity.
Part of the program. Yeah. I was doing I was having a guy do an experiment for me with talking about density and that it's the mass that's the reason why things drop and not because of the density. I'm just going to end up going in a couple different directions here. So sorry. So it didn't occur to me to ask him at the time, but if you have a helium balloon that goes up into the sky, and so if you just get a whole bunch of helium, if you get 100 times more helium, will that start to fall?
Well, because
probably not. Yeah, it'll just go higher faster.
Helium is lighter than air, but if you go high enough, helium stops being lighter than air, and then it finds its own layer up in the atmosphere.
Yeah. So that has to do with something.
Yeah, gravity, buoyancy, density. Yeah.
It could just be the fact that when it gets up higher and the air is less dense, then the issue of weight changes, and so it won't be rising anymore because it's starting to get to be the same weight as the medium it's in.
Yeah, same weight. What is weight? Weight is a cause of gravity.
No, we don't know that. Gravity is a theory.
You have mass and you have mass and you have gravity, and then you have weight. That's simple. That's pure mathematics.
No, gravity is a theory. It's what people played around with numbers on a piece of paper. It has never been proven.
Because we live on the biggest mass of gravity. You know when you have
because no one has ever shown it actually working.
When you have comets and
as your testing, as your lab experiment.
When you have comets and meteorites that are entering our solar system, and you see them go around the sun, they measured the track or the trajectory of that comet, and they can calculate it around the sun, and they can calculate that it would hit us in 15 or 20 or 200 years. That's because of gravity. They can calculate it around the sun.
Show me.
And Halley's Comet, it's a perfect example. Every 72nd year. Halley's Comet. I'm no scientist. But how can Halley's Comet be here every 72nd years if having gravity?
You're doing the same thing you accused me of, where you're using this as an example that you can't show me evidence for.
But this is daily observations from many thousand years ago.
Show me the calculations and show me the experiment. Show me how it was measured.
I'm sure it's on the internet somewhere.
You can't do it. Show me the guy who did.
It's named Halley's because of Halley. He did it.
Show me the guy who did right now.
He's dead.
Well, not that actual guy. The guy who has also looked into it and figured it out.
Yeah, but this is daily observations again. How can you deny
No.
daily observations?
It's not daily observations. I don't see Haley's comment every day.
Every 72nd years he's here. That's a
I
cause of
haven't seen
gravity.
it every 7 years.
That's a cause of gravity.
I haven't seen it every 7 years. It's not a
70
daily
second.
observation for me or anyone else that I've met.
72 years. Every 72 years.
I haven't seen it every 72 years.
No, but I don't remember the last time. But it follows a path every 72 years, and that's because of gravity, because it goes around the sun.
Or it could just be something else that happens every 72 years and that we've worked out a bunch of math to make it appear like we know what's going on when we don't. Because everybody who I ask says, well, it's some other scientist who did it, and they don't have it ready to go when they bring it up.
Like clockwork, yeah. That's the same with the tides. Every 12 hours, 24 minutes, you have the tides. Like clockwork. How does that happen on a flat Earth theory?
We don't know. That's why we're saying we're going to do experiments.
Yeah.
That's why we're waiting for everyone else to do them.
What
Or
else?
at least show the ones that the glow people are doing, and no one has the experiments to show.
But that follows the exact same path of the moon. 12 hours, 24 minutes, like clockwork, and it does that for several thousand years.
Well, they seem to be interrelated.
Related or unrelated?
They seem to be related.
Yeah. Because the moon's gravity field pulls the water.
There's no such thing as gravity as far as it actually being proven with experiment. It is a theory.
But how can it be coincidental when it fits the same model for so many thousand years? And it's predictable.
The moon and the tide are related doesn't mean it has to be gravity.
The tidal is predictable to follow the sun, to follow the moon and the sun.
But because it's predictable doesn't mean it has to be gravity.
What else could it be?
It could be a lot of other stuff. We might not ever know.
I heard someone call it underwater volcano or something. That, yeah, but again, like clockwork, every 12 hours, 24 minutes for thousands of years, and no.
It doesn't mean it's gravity.
This is like, I hate to pull it up, but Occam's razor. When you have two equal evidences or proofs or something, which one is the acceptable one or least acceptable or something? That's
the one that makes the most sense.
Yeah, but and then you have the tides.
You have an experiment to show to substantiate.
Yeah,
alleged gravity doesn't exist.
But then you have it follows like clockwork for every 12 hours, 24 minutes. What do you say?
That? Dropping a pen on the floor is not an experiment unless you can show someone doing it, under the earth and show a picture of it, someone standing upside down, dropping a pen on the earth and watching the pen go up into the center of the earth.
But if you saw a video of someone doing it in Australia, you don't see it upside down, you see it the straight way, because Australia is not down.
You wouldn't see one of our 10,000 satellites that could zoom in and watch it happen.
Yeah, and Wade's Underworld did just that. If you see Wade's Underworld on the internet, on the YouTube, Wade's Underworld, he has shown pictures from Himawari 8, the weather satellite over Japan, and he saw outside his door, and he follows the weather exactly. He saw the line of clouds over his house, and he saw the line of clouds on the internet on Himawari 8. It matches perfectly. He had a forest fire. He saw the clouds from the forest fire in a straight line, and he had a sandstorm behind him. That followed exactly the same on Himawari 8.
All right, well, I'll look into it.
Wade's Underworld. See his videos. That's you don't even try to debunk that one.
Yeah, I'll take a look into it. So, well, all right, man. Thank you for your time. It's getting late over here.
Yeah, it's
Did you have a good time?
8:30 a.m. here, so it's morning. My kids are getting up.
All right. Did you have a good time?
Yeah, sure. It's my first debate, so.
Well, very good. Thanks for your time. I'll take a look into some stuff, and hopefully I'll be able to connect up with you later on.
Thank you so much.
Anything more on your mind?
Huh?
Anything more on your mind before we go?
No, I think we covered the most part.
All right. Well, have a good day.
Merry Christmas to you.
Yeah, you too.
Take care. Thank you.
All right.
Goodbye.
Yeah, bye-bye.